Hello and welcome to this session on increasing the rate of experimentation with Azure Machine Learning. I'm Sandhya Vankamamidi, and I have here with me my colleague, Ahmed Geiger. And we are super excited to be here presenting all of the cool capabilities that we have in the preview. So we've been having a lot of excitement about the Microsoft AI platform. We had some great demos yesterday. We also heard I cannot see my cat dead and alive at the same time, a really cute statement from Satya yesterday. But with all of that AI and machine learning stuff that's going on, the one that I want to focus on is actually the Azure Machine Learning preview. And that's where we're going to spend the next hour plus. With Azure Machine Learning preview, we're shipping 4 things: the experimentation and model management services in the Azure, and we're shipping the the Azure Machine Learning Workbench and the Visual Studio tools for AI, Visual Studio Code tools for AI. My apologies. So with that, I do want to emphasize that the Azure Machine Learning is a key component of the Microsoft AI platform, because what we're doing is enabling the end-to-end experience of building the AI applications. When Amit and I were kind of looking at this and wondering, how are we going to present this? Like, how do we get this together in front of you in a way that actually makes meaningful sense? We decided to go with a single scenario across all of the capabilities that we're demoing, and we picked the Boston Hubway data set. We essentially picked that for 2 reasons. One, it's a great cause. It's an environmental cause. Bike sharing is great. So working on anything where we actually use ML to produce a prediction that will enable them to perform better is honestly for the greater good. And the second, of course, is it's a very cool demoable data set. So you will see that in a second. So what we're going to do is, before we jump off and start looking at the cool capabilities, we also want to go ahead and take a look at how do we set up these accounts. So I'm going to take a quick demo detour and take you through the process of actually getting one of these accounts. So I have here 6. Yep, perfect. So I'm here on my portal, the Azure portal. And I'm looking at my dashboard, and I click on the new and jump into AI and cognitive services, and bam, right there at the top, I have the 2 preview services. Now, one of the key things to kind of understand is that as you create your experimentation service, it automatically can provision a model management service for you, so you don't have to do this in 2 steps. So I'm going to do something really simple. I'm going to create something. I already have a subscription that I can use, but I think I'm going to go ahead and pick something else because I really want that to go under that account. I am going to create a new resource group, and I just keep the rest of it as standard. And one thing that I do want to call your attention to is that there are 2 accounts, 2 user seats that come free with the Azure Machine Learning Experimentation account. And if you actually press here, the model management pricing, you can actually see that there is a dev test, which gives you 20 models for free, and 2 deployments and 4 cores. And you can always scale up to S1, S2, and S3 as your kind of business needs it. So I'm going to keep it at dev test and go ahead and create this. Now, what happens when this creation takes place is essentially all of the backend resources for my accounts are getting set up. And once the setup is complete, what I will be able to do is I will be able to go to my Azure Machine Learning Workbench, and I will be able to see that particular account show up here once the provisioning is done. But in the kind of interest of time, what I'm going to do is take you through a demo account that has already been set up, and we will continue our demos from there. So before I get into the next part, I just wanted to call out that as the data science workflow, we see 3 clear steps as we look at it. The first one is, of course, prepare data. Then there is building the model, And of course, the last is operationalizing it, putting it into a production system where your users and your business applications can get to this model and actually work with them. So for that, what we're going to do is take it in 3 parts. I'm going to be covering the data preparation, and Ahmed here will be looking at experimentation. And for operationalization, we do have a complete deep dive session, which we will refer to at the end of this. So you can go and take a look at that session. So I'm going to first start off with a quick demo of our capabilities in the space of data preparation. So what I have here is I have the Azure Machine Learning workbench. And in my Azure Machine Learning workbench, you are seeing a list of projects at the top level. And these are all the different workspaces and the projects under the workspaces that you can see. You also see an app-level homepage. There is some really great capabilities and tutorials that are actually listed off of here. Absolutely make it a point to click into these. These are being refreshed all the time and will definitely help in terms of getting the onboarding process completed. So I'm going to go ahead and click into my the project that I've already created. And in the project that I've already created, I do have a project dashboard, which then again is a great place for me to put down all my notes. There is a markdown file that I can edit and put data into that will just show up here. So it's actually everything is really easy and simple for me to get started. I get to the data tab, which is the tab that I am going to be focused on right now. Because as a part of data preparation, one of the key things that we have focused on is we've heard over and over that the data processing times in any machine learning project amounts to about 70 to 80% of the effort. And it is time consuming, it's stressful, it's often repetitive, and not to mention, it isn't very easy to reproduce. So one of the things that is the value prop of Azure Machine Learning Workbench, Azure Machine Learning as a service, is that we have focused on making data prep super easy. But more interestingly, we've actually used ML for data preparation. So you're going to see some magic around how we actually take data and then convert them, make it easy for you to do the data preparation steps like that. So while you actually see a few files up here, they are just my backup demo files in case the demo gods don't smile on me today. So please ignore them. We're actually going to try and do a full live demo. So I'm going to go ahead and pick up my file. And I am going to pick that up from an Azure blob. And the reason I'm doing that is because the Boston Hubway bike share data is quite large. So I have all of my stuff already in a blob. And I would prefer to work on it. But because the data is big, I would probably prefer to sample it down. So I'm going to go ahead and connect to my blob here in just a second. I'm picking up my container, which is the bike share, and there is the Boston weather data that I want to pick up. So with this data, what I'm going to do is, again, it's a pretty simple CSV file, so I'm going to let this particular selection be, and I'm going to skip ahead. You can see that it's actually giving me a preview of all of the columns and the types that it's actually identifying. You can also see that it is letting me bring down 10,000 rows of that data set. Again, this is, because this data set happens to be an Azure blob, it's a good idea to actually have some kind of a sampling strategy and bring down a smaller subset. There are other sampling strategies that we'll look at in a little bit. You can do a couple of other ones, and which could work better for you. For me, the data is pretty straightforward, so I am going to do a top 10,000. So I'm going to go ahead and get that data down. And once I have that down, I have some metrics at my fingertips. I haven't done anything, but yet I'm able to look at these visualizations. I'm able to choose some metrics and kind of add in the metrics that I think are the most useful, right? And from there, I can actually make decisions on what I want to do next. So I go to the next step, which is prepare. And at this time, what it's doing is it's asking me if I want to create a new data preparation package. In this case, because like I said, I have a backup data preparation package, we'll ignore that, and we will say demo deep prep. as my data preparation package. So now I'm in the data preparation package. Let's take a look at exactly what's going on here. So there is a date field, there is a temperature field, there is some humidity, and some wind speed. So this is data that's coming from the Boston weather stations. And what we're going to do here is I'm going to start off very simply by taking this and saying, well, I really want the date and time to be handled differently. So I'm going to go ahead and split it. Now look at this. This split was actually pretty smart because there are quite a few delimiters in here. There is, of course, the hyphen, and there is the semicolon. But it actually was smart and actually kept the split along the split between the date and the time. It did not go ahead and blast everything out into really small columns. But there could be a point where I might actually want to get features that are specific to months, in which case I would further split this data on month and get the month out. But I'm not going to do that right now. What I am going to do, though, is I'm going to go ahead and derive this particular column because I don't like to read the date field just like that. So I actually prefer to actually read it in this format. So now what you could see is it was reading that date field, and it was analyzing it. It came back with some suggestions even as I was doing work. It prompted me to say, hey, maybe you want to do Feb, maybe you want to do Feb 2nd, maybe you want to do something else. So there are like 3 or 4 options that it is coming back with. And with that, what it also does is it actually goes ahead, runs these transforms, it figures it out, and it comes back and prompts you. So it's prompting me to look at another date, which is Feb 9th. That kind of looks OK. And so I'm going to go ahead and just click Enter. And with that, I am done with my the date extraction that I wanted to do. I'm going to go ahead and do something similar for this one, except let's make it a little bit harder. I am going to go ahead and map this into an 8 p.m. to 10 p.m. block. So it's interesting that I am taking this and actually making bins and putting them into those bins. And it comes back and suggests, and it seems to have done a pretty good job. It has actually picked all of them. And it does want me to look at one more row. So I go ahead and take a look at this. That sounds about right. So I confirm, and I'm done. So with just 4 clicks, I have transformed 2 fields. Now, you might say, big deal. I'm a great Python developer. I can do this in a second. Sure, absolutely. So now what I go ahead and do is I actually take the 2 fields that we created. Let me go ahead and first drop the fields that I don't want, because they're really in the way. So I go ahead and drop them. Now, one thing to note is that it isn't really deleting those columns. All that it's doing is just going back one step will bring those columns right back into the view. So this gives me a lot of flexibility. I can try different things. I can keep going forward, but I'm not comfortable with it. I just click right back, and I'm back at the place where I could have picked it up from and gone a different direction. So it's super handy, super useful. Nothing really goes away. It's all being done in memory. So here I am. I picked the column that I just created, and I am going to go ahead and combine them now. Now here is something interesting. What it did was it was smart enough to say, OK, that's pretty simple. I'm just going to put a comma in between the 2. But I don't like commas, so I'm going to go ahead and go to the advanced mode and say, well, I don't like commas. I want a space in between, because that's the format that I'm looking for. So it went ahead and did that super easily, just converted it and put that field together. Now it's time for me to go ahead and drop these sets of columns. So now I have a date field that I really like, and I also have 3 of these fields. Now let's go ahead and take a look at what we would do with these fields. What I want to do is I want to go ahead and summarize the data, and I go ahead and pick that. I drop my date field here, and I want to summarize on the mean for these columns. So I pick the mean, and that would actually help me get to my next step. Mean looks way better than actually looking at individual values. But what I would really like to do is go ahead and do something of converting these values into a number between 0 and 1, right? Because that performs way better with my algorithm. So in order to do that, that isn't a supported feature. So what I can do is I can do something called transform data flow. You can see that there are these 4 options in the tool. All of these are the escape hatches that we have where you can go in and work on extensibility and bring in the code that you want to execute on either the entire data set, or you can actually execute it on a specific column or a partition. So I have the script handy here. I don't need to really go ahead and write it. So I got that, and it went ahead and did what I wanted. So this was pretty good. I think I'm pretty much done with this data set and the way this particular data is looking. What I can do now is quickly switch back and give you a quick summary before I head out and look at the other pieces of data that we're going to bring in. So what did we look at? We looked at, reading the heterogeneous data, sampling, flattening, and distilling structure. We also looked at understanding and making the data valuable, and transforming, extracting, and combining them, right, into meaningful ways. And we also looked at reshaping and aggregating the data in a way that, again, makes it more meaningful for the next step in the process. The important thing about the data preparation flow, though, is we don't just leave you with a tool that actually you do cool stuff in, but then what next? So there is a really clear path that we will show you as to how you get from the data prep and take that data into experimentation and do all kinds of crazy and cool things with it. So what did we see specifically in the data preparation demo that we just had? We looked at data stores, the data type, the file types that you can actually have. We also looked at sampling strategy, but I actually promised you that I will talk a little bit more about the sampling strategy later on. So let's talk about the different options we have. So we have 4 at the moment. We do support, well, one of them is full. It isn't quite a sampling strategy, but it's an option. So there are 3 different sampling strategies: the top N, random N, and random percent. Now, one thing to note here is that when you do random percent on data that's actually sitting in the blob, you can connect your sampling with a remote compute so that you can perform that random percent computation before you bring the data down, because you really want to make sure that your calculation is happening well, and if the data is really large, you do need that additional compute, and you can actually do that. So let's look at what the coolness factor, where the coolness factor is coming from. So this is actually a very cool imagery that I found about the program synthesis using example capability that we are heavily leveraging to actually do the 3 things that I was showing you: the derived column by example, the combined column by example, and the split column by example. So this capability is coming to us from MSR, and it's pretty, it's pretty logical. It's very cool. It's pretty logical. But what they're basically doing is the user specifies an intent, which is an input plus an output pattern and an input. And there is a program synthesis framework which goes in and generates a set of programs that are possible. And typically, these tend to be a huge number of programs. Huge number of programs that might actually fit that example in many, many different ways, right? And for each of these transforms, there is a specific data specification language. So combine has its different language. The derive has its own language, and split has its own language. With all of these put together, then there is machine learning applied to it to figure out which does the program think will be the one that you would like the best. And so there is a winner that gets identified by that machine learning algorithm. And that's what you see. When I actually hit that, you actually saw the transform show up. Life was awesome. But because there are other additional transforms, there could be an edge case where you might have intended for a different thing. Like you might actually have wanted something else, and we are trying to suggest a particular route. So what it does is it's smart, and it gives you a way out. It gives you a way out in 2 ways. It gives you a way out by saying, give me some additional examples. That's one way of doing it. But the other way is you can just say, I'm going to go into the advanced mode and take control of this whole process. I know exactly what I'm doing. Let me do it myself. right? So there are two ways, two hatches in some sense that can help you. So if it mostly gets it right, if it doesn't, it prompts you, and there is always a way that you can get out of it. So let's look at, I did want to talk about the split column by example a little bit more, because there is something really cool hidden in there. Typically, splitting is delimiter-based and pretty cool stuff. It's easy to do. You can mostly do it straightforwardly. But the nice part about this one is that we do add some additional capabilities because we're using machine learning underneath. So what we're doing is we're looking at some data patterns that are common, and we're adding those into that machine learning capability. That is picking those programs that we just talked about. We're also looking at multiple arbitrary delimiters and making a use case and a set because of that. So let's take an example. Let's say that you actually had this really interesting string, which is the store open and close hours that's coming to you from some web page in the internet, and you needed to use that and make features out of it. If you send it through the splitter, it actually splits it very interestingly, because it is smart enough to understand that the hyphen between Monday and Friday is important. The semicolon after Friday is actually a delimiter, so you really don't want to put the next two things together. However, it's smart enough to know that the semicolon between the 7 and the 00, it should not split. And that's important. It's important because what it's doing is it's actually understanding the components of the data that's surrounding us, the data patterns that are surrounding us, and it's able to tell that, oh, 7:00 looks like a time. Maybe I don't want to split it in the first go. Maybe if the user really wants to split the time into hours and minutes, they will do one more split column, and they will get to what they want to get to. Let's look at another one. So this is an IIS log, and the data here is interesting. Let's see what the split column does. So it was smart enough to actually identify an IP, and that's pretty cool. It's a pattern, again, that it has learned, and it takes the IP number, puts it out separately, and then it also makes sure that it's getting the timestamp and the additional offset separated out into columns, because you can actually use and work with the timestamp without having to worry about the offset. So again, the reason I wanted to show you these examples is because there is a lot of ML happening underneath the covers. It isn't really exposed to you. However, you do have control on it. So it doesn't just go haywire on you. It's not like it's not going to listen to you. There is always that advanced mode button at the top. Please click on it when you try it out and give us feedback. OK, so last couple of things that I wanted to talk about is there are a bunch of transforms, and we looked at quite a number of them. And let's actually get quickly back into our demo for the rest of the data so that we can put it together and create data that Ahmed can use in his operationalization. So I am here, and I am looking at the demo dprep, right? I want to go back and bring in one more data, and this is the trip data. So I go back to my blob and do a really quick pass at bringing back the data that I need. And it's one very, very curious thing here is that a lot of people do work with data that they have downloaded on their laptops, and that's perfectly fine as well. If you have the data within your laptop, you can connect to it, and there is a pattern, and you have this in the documentation online. You have a way in which you can actually go in and connect that data, that connects the data preparation file that you did with all of the cool stuff on your lab with the data on the laptop, but then point it to the bigger data set in the cloud. And that's important so that you can do your data prep completely on your laptop if you so wish, but then you're able to just take that data prep and run it against a data set in the cloud. I am not going to demo that right now, though. So I'm going to go ahead and pick up one of the trip data, which is for the month of Feb. And I am going to go ahead and finish that. So again, the trip data is pretty interesting. It has some detailed start times and station times, where the station came from, and so on. And with all of that data in, what I am going to do is go ahead and add this to the preparation file. And what just happened is it opened up demo dprep, and you can see that there is the data flows here, and you can see that it added it as the second data flow. So let's go ahead and click into that one. So some of the cool things that we can do is you can go ahead and click on lat longs and bring in the map. Oh, sorry, my bad. Let's take a look at that. Oh, where's Boston? So that's pretty cool. I am missing my Boston. That was a zoomed out map. Okay, there we go. So all of the different stations start showing up on the map. Those are the latitude and longitude of the stations. But in the interest of time, I'm actually not going to head down that particular direction. I just wanted to make sure I showed you that there was the capability to do maps from right within the data prep tool. I'm not going to take that particular demo path because I do want to get to a place where we can join the data and then hand it over to Amit. So this is an interesting data set. So from here, where I go is I look at the trip duration, which is my key. Now, the trip duration, if I actually do a quick histogram on it, it tells me that something is really interesting and odd because I get this really odd histogram. So I go ahead and look at the column statistics, and that clues me in that there is this maximum, which is this really odd number. That's a really long trip duration. Wow. So I want to go ahead and take that out and make sure that my data is clean. So what I do is I go ahead and I add a column script. Again, I use my famous notepad as a cheat sheet and bring in what I want to do, which is basically just a log function. I give it a name, which is log trip duration. And bingo, I am done. I can go ahead and then look at this new column. This new column then is something that I can do a quick histogram on to check if it looks reasonable. And yes, it does. And that's because we're actually trying to eliminate all of these really wacky outliers by doing the log function. Now, it's still not fully correct because I can see a really long tail, and I wonder what's going on. So what I do is I look at the fact that most of the values are kind of till 9, and then there's a huge long tail. So I go ahead and I filter this column out and reduce it to all the things that are less than 9. Now, it's interesting. It actually did fix that, but it actually didn't fix it completely. But that's because what we do is we actually have something called halo effect. So we're showing you where the graph actually had data before and what changes you're making along the way so that you don't kind of mistakenly go down a path of trying to make changes that are significantly different from what your original data set was. So in this case, the halo effect was causing that chart to not show up correctly. So I went ahead and removed the halo effect, and what it's showing you is the actual histogram of that particular column. Sounds good. I just have a few more steps before I actually am ready to go ahead and get to the next step, which is to actually work on the experimentation. So I've done a lot of different processings on this, but the two columns that I really want are just the ones that I want to keep. Everything else I'm going to get rid of. So there's the date, and there is the station. So all I need to do is get this date back in the same format that I actually had in the other file so that I can get these columns matched up. But I did that in quite a few steps in the other place. Now, I'm going to try and see if I can do that in one step. Let's try that. So I'm going to go ahead and give Feb, and it prompts me, which is good. Awesome. And then I'm actually going to go ahead and say that I am looking at 12 a.m. to 2 a.m. as an example. Now, this process that it's doing is actually significantly more complex. So it is going to ask me for a few more responses, and it is going to, again, get a few of them incorrectly, right? Because what I'm doing is, instead of doing 5 steps, which were very nice and discrete, where I separated out the date and the time and then did the processing on it and then combined it back together, I'm actually trying to do something super complicated, but it got it mostly right. I can see a couple of options that are a little off, so I'm going to go ahead and fix that. This actually should be, again, 12 a.m. to 2 a.m. and not 1 a.m. to 2 a.m., so that my buckets are all 2 hours apart. Okay, so that actually did a better job of breaking up all of those buckets, and they look pretty good. And while it's still analyzing, I'm going to go ahead and click OK, because I'm quite confident that this does work. And I am going to step ahead to the next part so that I give enough time for Amit to do his stuff. So now that we have 2 of these, I'm going to go ahead and join them. And that's pretty straightforward. I go ahead and use join. And in my join, I select Boston weather and my Hubway trip data, and hit next. I select the columns that I'm really interested in, which is the 2 date columns that I have. And you can see that there is actually a Sankey diagram that shows me that there was an intersection. The reason why this intersection is small in this particular case is because, like I said, I took a sample of the data from Boston weather, and I also only picked up 1 month of data, right? So I only picked up Feb, which was the month that it's actually doing the join on. But when I run this on the entire data set, you can actually see that it would be a larger join set. But with that, what it did was, now I have a completely finished join result. And this join result is what I would like to go ahead and run. So my next step would be that I want to go ahead and run this particular thing on an HDI cluster. And I want to get a quick access Python snippet that can get generated directly from here. So what I did was I actually right-clicked on demo dprep, I clicked generate data access code file, and it automatically generated this little tiny piece of data access code. What this is doing is it's actually telling us that it is going to go ahead and run package.run demo dprep, and it's actually saying that the data flow that it's going to run is in the position 0. What we know from looking at the demo dprep is that the data set that we really want to run is the data flow that we really want to run is the one in the position 2, the index 2. So I'm going to go back into the actual the Py file and change this index to 2. And at this point, I am ready to actually run this on the HDI cluster that I have created. Now, it is important that, and Amit will be covering this more in the experimentation, that when you submit a file, you actually will see a small jobs pane, and it will actually go ahead and keep updating as that particular process is running and getting to completion and so on. So let me switch really quickly back to a quick summary. And we looked at understanding the data. We looked at inspectors. And we worked with quite a number of these inspectors in the demo. We also looked at custom scripts and extensibility. There is a good amount of extensibility capability built in, so please try out all of those really complex things that you do with your data. And if you get, if something is not working for you, do let us know. We would love to hear from you and provide that capability. And in summary, I think it's important to say that we generate code for the code that I just showed you, the generation of code. That data frame, if it's executed in a Spark runtime, it executes a Spark data frame. Whereas it actually produces a Pandas data frame if you run it in a Python runtime. So we handle that for you. You don't have to worry about it. All you are doing is executing that code snippet. You get a data frame, and after that, you're good to go. You can use it however you use it in your regular the rest of the experimentation. And for this, I'm actually going to skip this because Ahmed is going to cover it, because I do see that I'm running a little bit short on time. So I wanted to cover collaboration and Git really quickly before I hand it over to Ahmed. So I've been working on this really awesome project, but my managers just pulled me out and said that, okay, you need to actually work on something more important, different. So see if you can get a colleague to help you out. So I said, okay, let me talk to Ahmed. He's really nice and kind, and he would actually help me. So he is going to help me work this project from here on. And what we're going to do is actually take the fact that each of the projects in Azure Machine Learning is actually backed by a Git. It's a local Git, and it is automatically backed by Git. Subsequently, I can, in the project creation time, I can specify a Visual Studio, a VSTS Git repo, a cloud Git repo. And once I provide that URL, things just light up, because now I can use the same project on multiple machines, right? I can work from home, I can work from office, and the project starts to roam. But it also is super helpful when I have to collaborate with someone, because all I need to do is to make sure that the VSTS Git repository is something that Ahmed has access to, and I give him access on my side from the project, and add him in, and we're good to go. And so that's what I've done, and with that, I want to go ahead and hand over to Ahmed.
All right. Hello. So I'll start by doing the experimentation. I'll go directly into the demo as well. So Sandhya did all the data preparation, and as she mentioned, data scientists often admit that they take up to 80% of their time just doing the data preparation. So this tool should really help reducing the time spent in data preparation. But once the data preparation is done, we go to the experimentation phase, and that's where the data scientist is really actually writing the code to fit the data to a given model. So here's what I'm going to do, is trying to fit the data to a model. As you can see, I have the analysis of Boston bike share folder here, and it's not yet downloaded to my PC. So I'm clicking on the down arrow, and it's going to download the file directly here. That works because Sandhya matched a project to a Git repo that is in the cloud. I have access to it, so I can just download the file. And here I am. So I have my project here. I just need to copy some files so you don't have to see me doing some code writing during the presentation. Don't think it's the most exciting stuff for you to see. So I'm going here. Oops. Yep. OK. So now I am in this project. And so the first thing I want to do as a data scientist is explore the data and so on. But that was already done by Sandhya. And she kind of gave me some background. She said that she did apply some normalization on the data. We have a normal distribution on what we are trying to predict. So I can just go ahead and try to code. So we have, of course, a deep integration with Python editor. Our first language that we support is Python. Being Microsoft, we love VS Code, of course, but if you want to work with PyCharm, you can work with PyCharm, or actually any IDE that you want to. As announced yesterday, we have a new tool, the Azure Visual Studio Code Tools for AI that was released. And it's an extension that you can find on VS Code that helps writing Python, deep learning. It helps integrating directly with machine learning as well. So now you can see I have my project that is open in VS Code. So I will open my regression.py file, and I'll go directly to a line because I want to point you to a couple of interesting stuff. It's a bit below here. So I have my code already written. I'm not going to talk to this, but I'm assuming everybody is interested into learning Python or wants to do some scikit-learn. Here I'm using scikit-learn. And what I highlighted here is the call to our packages. We have an Azure ML logger package that allow to track metric run after run. So data science is a very iterative process. and you will do multiple runs to see if your diagnostic metric are going the right direction. It's often painful to follow how your metric are evolving, so the logger helps very much in that regard. And here I'm doing a random forest, and I'm logging the number of trees I'm using to do my random forest. Another point I want to show is at the end, I'm also logging some vector of values. So this one won't be shared across run, but they will be accessible within one run. So if you have a loop and you want to see how your loop is going, so if you're doing a parameter sweep, something like this, you can see how it's evolving. So that's how you will do it. Now to submit this job, I can just do a right click and do an AI submit job. We have this context menu that is lighted up because we have downloaded the extension. So I just click on AI submit job, and here it's going to ask me which run configuration I want to use. We come with something that we internally call transparent compute. So if your script is running on one compute, so on your local PC, you want it to be running as well magically on different compute. If it is a virtual machine that you have in the cloud, or if it's a HDI cluster that is as well in the cloud, or if it's another PC that you have on-premise, you want to be able to just click on one of the things and it works. So I'm going to do that. I'm just going to run on local for this one. As you can see, it's opening the terminal and it's putting a CLI command. The AML workbench comes with a bunch of CLI commands. Everything is doable from the CLI if you want to do it. And now it's kind of executing my user input, so it's just trying to find the better fit for the data. So now let me switch back to the workbench. And I want to see if how my run is doing. So I open the whole run, and I see that there is regression.py here, and I have some data already showing up. So the duration was the previous run made by Sandhya. You can see that I have tried submitting 10 for the number of 3, and you can see my R square for my randomization. So I want to try different number of 3s. So I go here, I select my regression.py file, and instead of 10, I'll go for 5, and instead of local, I'll go for my Docker. I have Docker installed on this machine, so it has already downloaded the image, it's creating a container, and it's going to push everything to the Docker. I'm also going to try the remote VM, and I'll submit, let me use a bigger number here, 29, why not? I had a failure. Anyway, I'm not going to debug that right now. So now I'm submitting multiple jobs that will all complete and then send me back the results. And then I can only see what's going on. Oh, so, OK, here the problem is the project that Sandhya had doesn't have the configuration I need. And I should be entering the scikit-learn directly here. So let me do a quick show. So in the run config and in the compute, it's where you give the configuration. And then the conda dependency also have some information. And here in the conda dependency, I should have scikit-learn. I don't have it, so that's why I know it's not working directly. Let me. I won't fix it, but it's running. Just I forgot to do that. So now in the run history, so sadly you don't see the result of all the run, but I could just select one of the run here. So on local, it's working. So actually, let me create some project on local, so we have some data sets. So I'm doing that, and I will also do with 5. And you can see we can submit multiple jobs in parallel. That's also working. So then I go back to my run history, and we are tracking all the jobs here. And I can just go to my regression.py, where we see how the jobs are performing, and I can click on one of the jobs that did complete. And you can see that was the vector of metrics that I was logging earlier, so the actual and the predicted value here. So what did I show you so far? So we have been to VS Code. We use the VS Code tools for AI. So that allows to connect directly to the functionality from the workbench. So you can submit job, you can list the job, you can go directly into a deep view of the job as well. And everything that we did here is also possible from there. So when I click on one job, okay, now I have more that are completed, and you can see that the metrics are showing me how it's doing. So for example, when I have 29 trees, it's showing me that my R square is 44, and when I have only 5 trees, my R square is 0.39. And it's also showing me which value is the best. So let's say I'm collaborating here. I'm collaborating maybe with Sandhya and with some other people, and we can look at this graph and say, hey, you know what? I think this one, the one with the highest R square is the best. So I just click on this one, and it highlights which one it is. So I can click on this, and there is a restore button. So this restore button allows me to restore the project to the state where it was when I did this run. It's extremely powerful when you think about the data science project that might last for a month or 2 months. You go back and forth, and sometimes you're like, oh, look, I lost all my code, sadly. I want to go back to a state where it did work, and now we are making that extremely easy for you. We also support comparing jobs. So let me go to the run list. So here I'm going to select 2 jobs, and I'm going to click on compare. And you can see we are putting side by side all the different parameters and the results of the job. If we have images, they will also show up there. All right. I think that's all I wanted to do for the quick demo. Now I'm going to go back to the slide and summarize a bit what we talked about. Was it 6? Sorry, thanks. So we talked about Visual Studio Code tools for AI. It comes with a sample explorer as well. So from VS Code, you can just do Control-Shift-P that bring down the command palette and write a sample, and it will give you a recommendation for a sample explorer. The sample explorer, you can just explore all the samples. You can click on install, and it will directly create a new project within VS Code. We have exactly the same functionality in the workbench, of course. The next thing we briefly touch about is the command line interface. So most of the functionalities from the workbench are available to a command line interface. It's also integrated directly with the Azure CLI. So if you have to create a DSVM using the Azure CLI, and then you have to move an experiment or execute an experiment on it, you don't actually have to do any UI work. You can just stay in the CLI. We also touched about the run history and the metrics. Here I had some more data. But you can see that each run you submit is being tracked. It's being added. We have a Git commit that is assigned to the run. This Git commit is actually a key for us to look back at all the metrics that you are logging and your different output artifacts. So you can easily go back in time and see all of these output artifacts. So we also cover about comparing run to another. We have a view panel. Oh, I didn't show you that, but you can actually select which of the metric you want to see in your run history. So if I go back to the regression, here you can see we have a wheel that allows you to choose which of the metric we want to check for. I also had the mean square error being logged here, so we can see that it's going up and it's going down. And again, it's being matched with all the other metrics. And we have the job panel. Sandhya already showed you. You also saw it. Every time we submit a job, we have an event that is added to the job panel, and you can see the progress of your job in real time. You can click on it, see what's going on. So now, regarding the transparent compute, I want to take a little bit of time to talk through it because it can be a bit confusing at first. So we have 3 files that are important: the compute target, the run configuration, and the conda dependency. The compute target is the file that actually defines where is your compute. So you will give the IP of your virtual machine or your HDI cluster, the head node. You will give your username, you will give your password, and we'll use that. And by the way, we encrypt everything, so you don't have security issue about that. And then we use that to connect to the machine and submit a job. The first time you want to use a compute, you have to do a prepare. So it's where we are going to install all the dependency you have, install the right version of Python that you have defined, install the right version of any packages that you have defined. And for the run configuration, you can set some settings. So if you have environment variable that you want to keep run after run, that's where you will define the environment variable. If you want to define some folder where you want to persist data or preload some data, that's where you will want to do it too. We also have an integration with the notebook. Let me show you that. So the Jupyter notebooks are tools that are very popular with the data science field. And we wanted to make sure that people can work easily with Jupyter notebook. So when you install an ML Workbench, we actually come with a version of the Jupyter Notebook 2 that you can run. You can also point to any compute that you want with your notebook, which is nice. So let me open a notebook here. And I can just say start notebook server, and it will offer me one of the remote compute that I already created. So here it's asking me which one you want to use. OK, let me go for the Docker one. And hopefully it's a bit better. So now it's starting the kernel. OK, so kernel is started. Let's see if it's running. OK, well, I'm really not lucky today with the demo. So I'm just going to walk you through all of this. So here I'm loading the Azure ML. I'm loading some, so I'm saying that the history is off at the beginning, so that when I'm executing a cell, it's not actually counting as a run history. Then I am just reading my data, and I'm also using the Spark ML pipeline. So you might have heard about Microsoft Machine Learning Spark, which is a wrapper that we developed and that we put out there in GitHub that wraps some Spark functionality and make it super easy to create a pipeline to do machine learning. I don't know how many of you ever tried to do deep learning on Spark, but it's very verbose. And using ML Spark, you can cut the verbosity by a third really easily. And then I was building some prediction here, so I was doing a fit, and then I was just taking some metric. Just want to point out that, again, it's exactly the same way of adding logs. And this one also tie back to the run history. All right. So as I say, we have a Jupyter Notebook experience. There is complete Markdown support. It's exactly as opening in your web browser. It integrates fully with our run history, our custom metric, and our versioning. So with Jupyter Notebook, one of the problems is when you are making change, you don't track the changes over time. Using our tool, you have the change being version now. And it can be accessed through a web browser if you want to. So you could easily, using Azure Machine Learning Workbench, create a Jupyter server that is on your HDI and then connect to it through a browser. So I talked a bit about Microsoft ML Spark. So it's a wrapper. I'm not going to go to all of these bullet points for the interest of time. But if you are doing deep learning and if you like Spark, you should go test it out. It's super easy to get started. We have a Docker image that you can download, and then you can just write some command that will directly get you started on doing deep learning on Spark. A last point I want to touch about, and let me quickly switch back here. So if I go back to my run history, so with the team, we agreed that one of the run was better than the other one. So if I select a run, I go on the run, I can choose the output I want. So the pickle file is actually a compressed version of my model. And this is the file that I would want to use if I want to create a web service to operationalize this model. So if I want to do some prediction or if I want to do some inferencing, I will use this one. And I can just promote it. So I just click here, and then the file is going to be promoted, and I can then download the file locally, which I'm not going to do right now. So once I do the promotes, we're actually creating a .link file. So the .link file is associating the artifact. So when you do the promote, we are transforming the artifact to an asset. The asset is an artifact with a version number. So if you want to make some update, you can track which version of the model is being deployed, and you can easily update your version of the model being in production. So the promotion is transforming an artifact to an asset. It's a way to create an association between an asset and a version. So we promote a train model so we can reference it in our scoring script. So when you want to go to operationalization, you will write a scoring script, which is basically the business logic you want to apply when a prediction request is coming to you. If you need to do any transformation and things like this, you will do it here. And then you can just point to your model when you are doing the prediction. And an asset can be downloaded locally to be used for creating the image when you are creating the Dockerized image of your web service. On your right, you can see that I've copied some CLI command how to do the operationalization step. As Sandhya mentioned, we have a session today at 4 p.m. By some of our team members. And they will go really deep into operationalization. All right, so let me summarize a bit what we did with the workbench. We are creating an open platform. So you can come with your open source packages. You can come with your proprietary packages. Anything you would like to use when you are writing code, you can use it with the workbench. We are really an open platform. Sandhya made a great demo of the data preparation tools. So the aim is really to reduce the time it takes to do data preparation before doing the actual data science work. We support agile experimentation as well. That means you can choose which remote compute you want to use. It gets very, very fast. Not using our tool to change an execution of a script to a different compute is really often painful. We track the data science provenance with the run history. It's super easy to go back and say, well, I actually used that data set. That was the script I used when I trained. And so it's an interesting value added in case of audit and things like this. We support operationalization at scale. Of course, when you create a container, it goes to ACS. And then well, it's Azure Cloud behind it, so nobody will have any issue handling any amount of traffic. And the collaboration and sharing, it was demoed by Sandhya. So the fact that she had her project being backed by Git, I could just access it and make it work. So that's the session that our friends are going to do today at 4 p.m.
That's right.
And so if you want to get started, just go on azure.com/ml. And we also have a bunch of different links to get you started. So you can download the workbench directly. At this URL, you can go to MML Spark at the aka ms.mml Spark. And you can download the VS Code tools as well directly from there. So I'll let you see some people taking a picture. All right. All right, now it's Q&A time, just in time.
So anybody here? What's the difference between this and the studio for Azure ML? Is it similar?
I can take this if you want. Sure. So the studio, really who we are targeting is different than for this one. So ML Workbench, we are targeting pro data scientists, so that people who are very well versed with data science. Azure Machine Learning Studio is more of a tool that we are targeting developers that want to add prediction to their current application.
Okay.
So it's easier to use the studio. You don't need to be a trained data scientist.
Okay. So
I can add to that. Think of the studio as an experience that you would use if you actually wanted to use the drag and drop experiences. It's a very powerful, but it's an environment where you have a lot of support. Think of the workbench as the place where you really want to be able to bring in all the third-party libraries and all the cool stuff that's happening, in TensorFlow, in Keras, and wherever it is, all the cool stuff that's happening, you can bring that in super easily into the workbench and get really deep and hands-on. So that's the kind of difference that I kind of look at.
okay.
Hi. Thank you for the presentation. Is this on? I don't know. Anyway.
Me? Sandhya.
Sorry, yeah.
Sandhya.
The dprep files, are you able to expose the Python code behind those, or is it always just sort of a dprep object?
So for now, it is a dprep object. And the idea there was that we do generate a Python at the time that you run it, but we don't really expose the code. We would love for you to use the tool and give us feedback if you think differently. We would love to hear from you, and as we get more feedback, we will definitely look at investing in those areas.
Okay, thank you.
I have more. But your data preparation stuff was awesome. Tired of writing Python code to do that. So you can't use that on the studio. I do a lot of exploration on just seeing if it's possible to do data modeling on things. So you can't, I guess you can export things, but it's not the same as the studio. That tool is much better than the prep in the studio as well.
That is correct. However, you can actually call the dprep from within the studio.
Okay, so you could
using a
use it
code
there.
block.
Okay.
Yes.
And the other thing is also we're in a regulated space where we can't do things online. Can you take your models offline? I know SQL has some integration with using models that you train in the cloud and use them offline.
I'm sorry, I did not quite understand your question.
Okay,
can you repeat that?
So once you generate a model, you can run it in Azure, obviously, but if you want to run it offline, like on-premise, can you do that as well? Are there tools for that?
Absolutely. Once you operationalize, what you're really getting is a Docker container. You can take that and even put it on Raspberry Pi.
Okay, okay.
So.
Thanks.
Hi, my question is, in one of the sessions yesterday, they showed us an Excel sheet where the auto-correction and auto-analysis happens automatically. Are these two different, or is it a similar functionality being made available in Excel?
It's the same. So what I showed yesterday was in Excel they were calling Azure ML function. So that's just a trained model that is put into Azure function. And then it's called directly from Excel.
Okay, thank you.
My question is, what size files can you realistically do this cleaning on? We have like 10 gigabytes per day that we have to clean. And then once we've cleaned it, that comes in every day and we have to somehow automate that. Is that realistic to do? And then second of all, the data we're using is time series data with duplicate rows, and we have to remove the duplicate rows and somehow average the values between those duplicate rows, or do some sort of algorithm on them. Are those things possible?
I can take that. Let me answer your second question first. We don't have time series as a component, as a supported component directly yet. We're definitely looking at it. Please do use the tool and give us feedback on the exact scenario that you're looking to accomplish. But having said that, you will be able to use the extensibility models that I showed you and use those to actually get your the Python code in that would actually do the work. Okay. So that would be the answer to the second question. As far as the first question is concerned, for you to be able to do the data prep and see it in the tool, there are, of course, limitations on the size of the data. You really don't want to connect to a 10 gig database data and do any kind of UI on it. So I would recommend sampling down, and that works beautifully. You sample down and you can actually get the data prep file. Once you get the data prep file, all it needs is an actually HDI compute in the back like I showed you, and you're actually doing the 10 gigabyte file processing on the HDI compute.
Okay.
So it really isn't being done, it's being done in the cloud, it's being done in Spark, which is large, hugely scalable. So that would actually help for your scenario number 1.
Okay, so then I think in other sessions they've recommended once you're done with an HD site cluster, you shut it down or turn it off. Is that correct? So the procedure would be to you do the processing, then you shut down your HD Insight cluster until the next day. Is that standard procedure?
Yes. So unfortunately, at this time, we don't have the ability to shut down from within the tool. So you would complete your work, and then you would shut down the HD Insight cluster from the Azure portal, and then bring that back up the next day when you want to actually do the work. But that's great feedback. That's definitely something that we're looking at to say, how can we make this a smooth process between the workbench and the
Because in addition to processing the data, the
Yeah.
sheer size of the files is an extremely tough problem to deal with, because you have a data store which can hold petabytes of data. You have to extract a small amount, which small amount being 10 gig is about as all you can do on a desktop machine. You've got to manipulate that and figure out enough of the fields, which would amount to downloading 10 gigabytes of data and uploading it back into Azure, because we're not storing our stuff in Azure. And then you have to then parse the fields out, and then you have to take it, and if Azure is not the storage that the machine learning is reading, then you have to also transfer that thing again. So it's just doing that takes hours of transferring data. So I'm just...
I would love to chat about your scenario afterwards if you have time.
Sure.
I would love to understand what your concerns are.
You may have answered my question a little bit, but there we go. If you change your compute context to use an HD Insight cluster, is the data prep file being pushed out to the cluster when it's running out there, or I mean, we're not actively transferring data between the HD Insight cluster and I guess your local instance, right? So if I take the experiment tool and say run with the configuration that's out on the HD Insight cluster, I assume that the data prep, there's something being pushed out to the cluster so that all that compute stays out there and just the results are coming back, correct?
Yes. Do you want to take it? I can take it.
The data prep is pointing directly to the Azure blob. So we won't be making that transfer. We'll just read from the Azure blob and move the data.
Okay, so the data prep,
Yeah, well, once she created, so data prep is pointing to a data source file, and the data source file is pointing to the Azure blob.
And I think additionally, so I think your question is, how does the data prep file actually land up in the compute as well?
Well, how does that, so you're getting a data frame from the data prep file, right? So if you're referencing data that's, let's say, out in a blob storage, so we've got, gigabytes, terabytes, whatever of data out there in the blob storage, and you are telling this script to run out in HD Insight. So you're executing from your workbench and you're saying run this script out in HD Insight. Those data prep steps have to occur, right? Because your script is only referencing a data frame that the data prep file is creating, right? So how are those steps, those data prep steps, being transferred out into the Spark cluster?
Got it. So basically what happens at the time of the job submission is that we actually do submit the job with the directory with all the files that are actually needed. So there is the data prep, there's the data source, all of that actually gets packaged and gets submitted. Okay. So the entire data prep package is actually available for that job. So if you looked at the little tiny Python generated code that I showed, you actually see that it's actually calling the package called data prep. Right. That data prep package gets submitted in the job run. Okay. And so it's able to access that. All of the code steps are inside it. So it has everything it needs on the compute for it to be able to access it.
Okay. Great. Thank you.
So I have a I can't say the word.
Operationalization. Yeah, see, we took a special course to just say that for, yeah, exactly.
Operationalization. And it's maybe a simple question, but so, you know, we're in this world now where we're doing R Studio, and we've got to make this transition into Azure ML, and we're working with Azure ML to do some really interesting stuff. So in the previous world, to operationalize, you need to create your models, you save an RDA file that has your model, and then you go work with it in R Shiny. So in this interim between worlds, can you create that RDA file with Azure ML still? What do you do?
No, we don't. So you are creating the RDA file just for presentation purposes, or?
No, we go use it, right? You create your model, and then you have an application where you're using it to score, you're using it to create other results. No, it's a model file, right? You create a model.
So that would be.
You save it in a .rda, .rds, and now you got to go use it somewhere, right? So you operationalize, right? So when you do that, I would maybe write a C# program that goes and makes those web calls and goes use that model, right? So in the world I'm in now, in the R world, you create that model file and then you go use it in R Shiny to create some results.
Sure. So right now we don't support R. Let's talk later about solution for your problem, and you should definitely go to the operationalization session later today. There will be able maybe to give you some hints, but yeah, right now we don't support R.
So you don't create the RDA file?
No.
Okay, great.
So when running Jupyter Notebooks within the workbench there, is it already containerized, not one working with the notebook on the machine, or is it looking for Python in the path?
You decide, actually. So if you want to point to local Jupyter, you can do that. If you want to isolate it into a Docker image, you can do that as well.
And when deploying the containers, I'm sure we already have access to pip, but do we also have access to other repositories like ContiForge?
Yes, you just, in the configuration file that I showed, you can just give the full URL of the repo, and then you list the packages that you want to download from that.
Perfect.
Hi. You show some metrics to evaluate the model, but are there customizable? For example, I need the adjusted R-square. Can you add?
Yes. So the metric was directly in my Python code. I was computing them, and then I added them as a custom metric. So that's why they showed up. So if you want to compute the F1 score, you can do it, and then it will show up. Just add it there.
Okay, thank you.
Sure, thanks.
Any other questions? If not, thank you very much. Really appreciate your time. And we're going to be here, so you can come back and talk to us. Thanks.